So hello everyone, and thanks for joining me in this talk after the fantastic lunch. My name is Claus Höfele, and I'd like to talk about developing apps for the Apple Watch. So the title of the talk is Practical WatchKit Development, and practical refers to two apps I worked on in the last few weeks. On the left, it's an app for eBay Kleinanzeigen. Kleinanzeigen is a classifieds platform in Germany, but similar to Craigslist in the US or Gumtree in the UK. And on the right, it's an app, a side project of mine called TransitHopper, which displays departure times of public transport services. So in this talk, I'd like to take these two apps as examples on how you could develop your own WatchKit apps. So the most important aspect of WatchKit development is that actually an app for the Apple Watch consists of two parts. One is the WatchKit app, which contains static resources. And the second part is a WatchKit extension, which runs on the iPhone and contains the actual executable code. And these two parts, they communicate through a wireless link. And as you can imagine, that incurs some delay you have to work with. The most important static resource that's part of the WatchKit app are actually storyboards. So you might know storyboards from iPhone development, but in contrast to iPhone development, storyboards have become mandatory. So you cannot actually create views in code for WatchKit apps. On the top, you can see the TransitHopper app. Apps are the ones you launch from the home screen. And it consists of these three screens. There are different navigation modes in WatchKit apps. Like you can either have a paged mode, where you can swipe left and right between screens, or you have a hierarchical mode, where you can actually drill down similar to your UI navigation controller. So for this app, I decided to use the hierarchical navigation system. At the bottom, you can see the screen for a glance. So a glance is something you launch from the watch face by swiping up. And it's a full screen, view-only screen where you can display some data. And every time you tap on the glance, it will actually launch you into the app. The third type of experience you can develop as a developer are notifications. So notifications are supported by default on the watch. However, you can improve them or customize them with code. So for one, you can use interactive. You can make notifications interactive, which means they have buttons. So in this case, Kleinanzeigen supports messaging between buyer and sellers. And what you can display is an answering button that launches the app and shows shortcuts, so you can quickly answer to notifications. What you can do as well are static and dynamic notifications. So static means you can customize the look and feel, the look of these notifications. And dynamic means you can run additional code. So an example would be you display a calendar event, and you can fetch additional data that you display when the notification arrives. So on the code side, so a storyboard is deployed inside the WatchKit app. So we are now on the code side that runs in the extension. So similar to iPhone apps, you have a WK interface controller, which is similar to a UI view controller. And it has also similar entry points, awake with context, which is similar to view did load, and will activate. And an interesting concept here is that awake with context actually receives a context object. So the previous view controller can actually hand a custom object to the next interface controller, and this is kind of the input parameter. So what I do, for example, I list all the connections in one table. So when you tap on that, I use the trip ID as a context and pass that to the next controller. Here's an example of how you would actually change the UI. So you can display maps, And it's pretty simple. You can add an annotation, in this case a red pin. You can set its coordinate, and you can set the region that's displayed in the map. So the important part of using these views in a WatchKit app is that most of its interfaces are setters only. So you can't actually read the value back, and this makes kind of sense because you're running this code in an extension, and every data you set actually needs to travel through this wireless link onto the app. And reading back would be difficult because that would incur another delay. So if you want to have the latest value, you have to remember it yourself. I mentioned storyboards, and most importantly, you cannot actually create views in code. So you cannot add or remove labels or buttons. So what you can do instead is hide and show them. So it's quite common to actually have some hidden views and then switch in between them. Another way to show dynamic data are tables. So basically, tables have a dynamic number of items. And this is what we do here in the Kleinanzeigen app with the conversation. So on the left, you have the conversation. You tap an item, and you come to a detailed screen, which shows the messages. And the way you customize UI elements in WatchKit is by grouping them. So grouping means laying them out horizontally or vertically and with different alignments. And what you can do with groups as well is give them a background image. So in this case, the messages have a little bubble image in the background. What's actually nice about this grouping is you don't have to calculate the height of the table cells anymore. It all does it for you. What you get also for free is dynamic type. So if someone changes the font size of the watch, it will be supported automatically as well. One issue that you have pretty quickly is if your list is dynamically and you can potentially have hundreds of items in this list, this will create a lot of data that you need to transfer to the watch. So what you need to do is actually page in. And unfortunately, you can't receive any scroll events. You can't page automatically. So really, you have to include a button in tables to actually say, yes, I need the next page. If you have a look at the Messages app that Apple created, they actually have these scroll events, so it works automatically. Tables also important is that you try to avoid reloading all the data if not everything has changed. Like try to work with inserts and removes, so to minimize the data that's transferred. I would like to show you one trick or perhaps a property that's not well known. It's called hides when loading. And this is a property you can set in the storyboards for your screen. And it basically determines if it shows if WatchKit shows an activity spinner while the data is loading, or if it shows a preview image. So maybe this concept is best demonstrated with a video. So you can see on the left-hand side, you have a sort of launch image, like similar to the iPhone app launch images. It shows an empty image, and then it fills in the data. This is when hides view when loading is off. And on the right-hand side, just quickly again, you can see an activity spinner all the time until all the data is there, and then the views and the data come in. So the launch image is a bit of a trick to make the transition a bit less noticeable, but it means basically the launch image that it displays is the setup you have in your storyboard. So it takes the setup in the storyboard, then fills in the data. So what you need to do is match the storyboard with the exact layout of what you will show after the data is there. So when you have used the Apple Watch for a while, I think you will be familiar with this screen. And that's basically an activity indicator showing an app is loading or a screen is loading. And unfortunately, as a developer, it's not possible currently to totally avoid these activity spinners. Hopefully, Apple will soon introduce a way to run code on the Apple Watch. But until then, there will always be a certain delay. What you can do, however, is make sure that the data you are displaying is there as soon as possible. And that means you have to work with caches, like you have to perhaps fetch the data in the background so it's immediately available, and then cache it so it's already can be displayed immediately when your app launches. So I'd like to talk about the data handling now. Again, the WatchKit extension is the part where your code executes, and this WatchKit extension is fairly capable. For example, in my TransitHopper app, I need to get the user's location, then make a request to retrieve trips from the current location to a destination. And that's totally possible to do in the WatchKit extension, except for one problem. The lifetime of the WatchKit extension is actually tied to the time the watch app is visible on the screen. So if the user actually swipes to the next app, then your WatchKit extension will be killed, terminated, and the data, when it arrives, actually won't be visible. So instead, Apple introduced a new API called openParent application. It basically means you can actually hand over some requests or some work to the iPhone app. And the iOS app is launched in a background mode, so even if it's not started yet, it will be started. And you can execute this as a background handler. So you have a couple of seconds, I think about 30 seconds to execute, and that's well enough for doing any requests. So calling this API is very similar. Basically, in WK Interface Controller, there's an API openParent application, and you pass it in a user dictionary, and you get back a dictionary from the iOS app. Then on the other end, in the iOS app, you have another UI application delegate function, and this is where you handle this request. And you should wrap it in begin background task with expiration handler, so to have the maximum time available for this background request. So openParent application, it starts the app, but in a background mode. So you cannot actually force the iOS app into the foreground. So instead, what Apple recommends you to do is using handoff. So for example, at Kleinanzeigen, we have login, but we don't want to have the login, do the login on the Watch app. Instead, we want to do the user do it in the iPhone app. So what you can do is you can show a little message, you have to log in, and then start handoff, and then the user can swipe up the icon and land exactly at the screen where he has to be. So that's an easy way to simplify the setup experience you might have in your app. A short note about user locations. So you can either request user locations in the WatchKit extension or in the iOS app. So a WatchKit extension is considered a foreground process. It means it needs different permissions than a background mode. So in iOS 8, Apple actually introduced two permissions for locating a user. One is called when in use. That basically means you can only use it when the app is in foreground. And an always permission, which means you can also do this in the background. So depending on where you actually retrieve the user location, you have to ask for one permission or the other. So when working with WatchKit extension and iOS app, these two processes, they are sandboxed separately. So by default, they cannot access each other's data. So you need a way to share data. And the way you do this is through app groups. So app groups actually have been introduced in iOS 7. It basically means it will create a container that both apps or extensions that are in this group can access. You need to add an entitlement to both the extension and the app, and then you can actually use this container in the app group. The easiest way to do this is NS user defaults. So NS user defaults can be initialized with they call it a suit name, but it's actually the app group name. And as soon as you initialize user defaults with this, actually everything that's stored inside can be accessed by all apps that's in this group. Apart from user defaults, you can also use core data. Basically, you create the core data stack, the store in this app group container, and then several extensions can use it. SQLite also supports being in this app group, but it needs application assistance. So you have to check with if you use a SQLite derivative API, you have to check if that works actually. And then there are a couple of proprietary persistence framework like Ream or Parse, and they announced support for this as well. So it's actually quite a choice in the meantime. So you store data in a shared container or shared database. So how do these processes know something has changed, right? And this is why you need signaling. And a simple-to-use API is called the Darwin Notification Center. The Darwin Notification Center works similar to the NS Notification Center, except it's not only within one process, it's actually it distributes it among several processes. And it's a broadcast mechanism, so basically you send it and every process that listens will receive it. So here's the API, it's a C-level, Darwin Notification Center is a C-level API. So it's pretty simple to use. You call notification center get Darwin notification center, and then you can post a notification. The trouble here is that these notifications don't support any user info. So you cannot actually send data with the signal. So what I do is actually I store the data in the user defaults in a shared app group, then signal it to the process, then the process reads it out of the user defaults. What you can do, though, is like all signals have an identifier, so you can attach a little string to it to provide more information. For example, I have a widget, a Today widget, a WatchKit extension, and an iPhone app. And in order to know where it came from, I actually attach a little string to it, so I know how to filter out messages from where it came from. So once you have set up a shared app group and signaling, this is what you can do. Basically, in this video, first the user changes the destinations and switches between destinations. Then you switch back to the Apple Watch, and you can do the same, and it synchronizes across all processes. And as I mentioned, I have a widget as well, so all the signaling and sharing data works across all of the three processes. So I talked about the user interface and data handling, and I would like to take a step back now and think about what kind of apps you can create or should create. The first quote I would like to provide is from the Apple Watch Human Interface Guidelines. A WatchKit app complements your iOS app. It does not replace it. So I think working with the UI in WatchKit is very easy, but actually knowing what focus to give your app or which parts to display in these tiny screens is actually a real challenge. So you have to put a lot of effort into interaction design and thinking about where is the focus of your app, what is makes sense on the watch. For Kleinanzeigen, we decided that messaging is a good use case, basically because it ties into notifications. Like notifications is something that arrives at your watch. You can notice them and answer them directly, so that's a convenient task you can do in a very short time. Glances, I think, are also very important because they have this, you look at them and in a few seconds you can actually get some information that you need. So even though maybe don't focus on the app itself, but see glances and notification, but see the app as a kind of landing page for glances and notification. I think that might be a good idea. The second quote is by David Smith, who is an iPhone developer who writes an interesting blog about, among others, Apple Watch development. And he says, anything that could use a progress spinner is a failure on my part. So this was written before the watch came out. It's clear now that developers cannot totally avoid activity spinners. However, you should at least try to have the data available. So if Apple fixes this issue or gives you new API to avoid activity spinner in the UI, that at least your data is there. And that means working with data caching and background requests. And I think this is technically the biggest challenge because caching, as you might know, is very difficult. The third quote is by M.G. Siegler, who is a venture capitalist, and he says, "Many of us, developers included, are still figuring out how this device fits into daily life." And this is totally true with me. I have my watch now for perhaps 2 weeks, and this is the very beginning. And most of the 2 apps I have developed, I had one opportunity to try them out on a real hardware, but otherwise we developed them in a simulator. So obviously it's clear that the next generation of apps will be much better and make better use of the hardware. And if you want to I think the best way to learn WatchKit development is by doing so. And if you want to exchange with fellow developers, I can recommend you Slack 5minutewatchkit.com, which is a Slack channel. Please join us and show us what you worked on. And this is what I had for today, and thank you for listening.
Thank you very much.